Biology, as you know, is the study of living things. And studying living things is really an enormous subject. In order to make it more organized, scientists have classified or grouped living things into different categories by how closely related they are to each other. And the first category is really called the domain. And there's the bacteria domain, the archaea domain, and the eukarya domain. And the one that we're going to mostly focus on is the eukarya domain. Because with eukaryotes, or the eukaryas, you're going to have the animal kingdom, which is what we're going to focus mainly on later on. After domain, you have kingdom. And when it comes to those domains, there are examples in a nice chart in your book, and you may want to take a picture of that at some point with your phone if you can. Kingdoms, there are 6 main kingdoms out there, and we talked about these last week also. First of all, there are the Archaebacteria, the Eubacteria, the Protists, fungi, plants, and the animal kingdom. So again, you have Archaebacteria, which are very old bacteria that have been around for millions of years. You have the Eubacteria, things like E. coli. You have the protists, things like amoebas. You have fungi, which most people think of mushrooms or mold. We have plants. You could probably name thousands of plants. And then you have the animal kingdom. The next category, when it comes to these levels, so again, all living things are placed into one of these categories. All living things fit into one of those smaller groupings. So if you're somebody who wants to specialize in Protista, all of those would be put into one group. After kingdom, everything's grouped into a phylum. So Archaebacteria have many phylums. The Eubacteria have many phylums. The protists have many phylums. The fungi, the plants have many phylums. The animal kingdom has 9 phylums. You are going to later on study all 9 phylums within the animal kingdom. Humans are classified into the chordate phylum. Once scientists have all the phylums, it's still a lot of organisms to study. So they decided to break phylums down into smaller categories known as classes. And humans are put into the class of mammals. And with class, you still have a lot of organisms, maybe too many to focus on. So they've taken every single class and they're broken down into order. And for humans, our order are primates. Orders are broken down into families. For humans, our family is hominid. Families are broken down into a genus and then into a species. And for humans, our genus is Homo and our species name is Sapiens. So here is the classification for humans. First of all, our domain is Eukarya and our kingdom's animal, but then chordate, mammal, primates, hominids, Homo, and Sapiens. So that's how living creatures are categorized or grouped in the biology world. Now, there is a technical name for classification when it comes to the science world. And that's known as taxonomy. So taxonomy is classifying living things into groups based on similar characteristics in DNA. At one point they strictly relied on similar characteristics, and they looked at embryological characteristics and all kinds of other things, but now we can do DNA testing. Taxonomists are scientists who practice taxonomy, and when trying to identify an organism, they will use the dichotomous key, which you're going to have a chance to use later on. A dichotomous key is what you would use when you have an organism out there, you don't know what it's called. Maybe you find a skeleton out in the woods and it's some animal and you want to know what it is. It could be a squirrel, it could be a raccoon, whatever. You could use a dichotomous key to figure it out. Dichotomous keys are used when the animal has already been put into the proper groupings, and then you can find its scientific name, which then can lead to a common name of the organism. And you will, like I said, be able to use some dichotomous keys as practice. So, taxonomy is the technical term for classification. Okay. All living things out there have a scientific name, which is the unique two-word name given to each living creature out there. Everything has a scientific name. And it's two words. The first word kind of describes the organism a little bit. It's actually what genus it was put into. And then the second word identifies it even more, and it's its species name. So the first word of anybody's scientific name is the genus. It comes from whatever that category known as genus. And then the species is what their species names happens to be. So for example, for humans, we are known as Homo sapiens, because our genus we belong to is Homo, and our species is Sapiens. Now, there were other creatures out there that have the genus Homo. They are all extinct now. Like there's the Homo habilis, Homo erectus. Those are extinct creatures, but we shared the same genus because we had some similar DNA. All scientific names are written in Latin. The reason it's written in Latin is because at the time when all this came about, every educated person knew Latin, and it's also a dead language. So the terminology doesn't change. There is no slang in Latin. And to be honest, knowing Latin now can help you with any science class that you're in, because a lot of things have Latin root words to it. Okay. Why is it important that we have scientific names for organisms? When we're studying things, living things, and people are doing research and they're getting their stuff published everywhere around the world, everybody has to be on the same page. Everybody has to understand what animal, what plant, what protist, what bacteria we are talking about, so that no matter where you live, you can identify and know the name of all organisms. There are common names out there. So let's say you go down to Mexico and you ask for corn. They're not going to have any idea what corn is. So you have to have this common language. And in the biology world, scientific naming is the common language for naming organisms. There's a certain way scientific names have to be written. The genus is capitalized, and the species name starts with a lowercase letter. Both words are underlined if you're handwriting or italicized if you're typing. So here's the example for us, Homo sapiens. It needs to be two words. If not, it's wrong. The first letter of the first word has to be capital. It needs to be underlined or italicized. That way, if you're reading, you know exactly, oh, this is a scientific name for some living creature out there. It makes it stand out. So in reading your chapters or reading things out of the book, if you see that, you know you're talking about the scientific name of something. I mentioned common names. Common name is an everyday name given to an organism, and it may be different from area to area, or something may have the same name for two different organisms. And again, that can be confusing. We can't have confusions in science. Another example of that is there's a plant called the yellow foiled tree leaf or something like that. That's what it's called here in southeast Iowa. You go up to northern Iowa and they have a different common name. That gets very confusing. So in doing research and getting things published, you have to use scientific names. An example of a common name for a bird, as you can see, robin, goldfinch, and you could probably name thousands of birds out there. That's just their common name. That is not their scientific name. And the person responsible for all this taxonomy stuff, for all this grouping, for all of this organization is Carl Linnaeus. He was the one that came up with this idea. At the time, people were traveling further and further and getting to know that there's these other languages, other people around the world. And he realized early on that we needed to be consistent, all on the same page. And so that's where they decided to come up with this classification system, grouping them by how related they are, coming up with the common names. And in fact, Carl Linnaeus changed his name to fit scientific naming. His technical real name is Carl von Linnaeus, but since scientific names weren't 3 names, they were only 2, he changed his name to fit that. Okay, let's talk more about the kingdoms again. And we're going to study, like I said, animal kingdom more than some of the other ones. But in the animal kingdom, I know you can name lots of animals. The plant kingdom, I know you can name lots of plants. Fungi. You have morels. You have mold. You could have any mushroom. But just so you know, a mushroom is the reproductive part of the fungi. The fungi itself is underground. Again, when you're eating mushrooms, you're eating the reproductive part of that organism. That's not the organism as a whole. Most parts of the fungi are actually in the soil. Protists, we have parameciums, seaweed, amoebas, which I can never spell, so I'm going to abbreviate. Eubacteria, we have things like E. coli. Archaebacteria, we have things that are called methogens. Okay. Like I said, and I left, you guys can name lots of examples for the animals and the plants. Okay. Then in the book, it talked about cladistics and phonetics, and you can read about that on your own. But the main thing is this last part on this page. Besides using internal and external appearances, or morphology, the way an organism looks on the outside and the inside, so besides just looking at that, scientists look at the DNA to determine how closely related organisms are to each other. They're using DNA, characteristics, morphology, and DNA to determine how closely related. There is a question, what do scientists use to find the name of an organism? Finding its name, you use a dichotomous key. But if you want to know how closely related they are to each other, you're looking at characteristics, and the big thing is DNA.